Okay, this is site 2 on the Anity Burn, and you'll see that the river has developed significantly since site 1. The surrounding landscape is mainly agricultural, which we can see there, and there's a small little river floodplain on the right hand bank of the river. Now in this tutorial I'm going to be looking at why the river has changed in the way it has done from the first location, and we're going to consider the same 4 key characteristics that we looked at in the site 1. So let's just have a think for a second what Bradshaw is suggesting in his model that our river should have done now that we are further downstream. Well, according to Bradshaw, our discharge should have increased since the previous site. Our bed load size should have got smaller on average, so our rocks should now be smaller compared to site 1. Our rocks should be less angular, they should be more rounded compared to site 1. And according to Bradshaw, our river should be becoming more efficient. The hydraulic radius should be increasing, and that's because there's more water in the river now and it's traveling through the channel more efficiently. So that's what we're expecting. Now when we look at our data and we analyze it, we may find that our results are not showing what we expect, and there are a number of reasons that we will need to analyze, and what we say is largely dependent on what our data shows us. And that's what I'm going to talk you through in terms of each of the 4 characteristics. So let's start with discharge. Well, what's very obvious, and without even needing to look at data, is our river's clearly got a much higher discharge. And the reason for that is, first of all, there has been 2 significant tributaries upstream from this location. And I'll put an Ordnance Survey map onto the screen so you can see the location of those tributaries. So to explain that, each tributary is discharging its water into the Anity Burn, thus increasing the amount of water in the river itself, which is why the discharge would be expected to increase at this particular location. Also, because we're now further down river, there is a much wider drainage basin now, which is capturing water and channeling it towards the river itself. Once again, that would explain why our discharge has increased. Now let's think about bed load. Now there is a very strong possibility, and if we look at the river we can see this, that actually average rock size is not getting smaller as we might hypothesize at this particular location. And the reason why average rock size is possibly not getting smaller, is probably getting larger, is to do with this large river cliff. Now what's happening on this large river cliff is we can see freeze thaw, where water's getting into cracks, expanding and opening up those cracks, and it's what freeze thaw is doing is it's causing rocks to break off the river cliff and land at the base of this cliff, which we can see all of the way, including that large boulder there, along the riverbank. We've also got another thing called root wedging, where we can see trees growing out of the cliff, and their roots are growing into those cracks, and as roots grow they expand. That puts pressure on the crack, and we can see a lot of rock, loose rock there, getting ready to break off. And when it does, it's just going to land in the river channel. So that's probably why your average rock size at this location is actually increased when you look at your data. It's that same factor which is why, if you are doing rock shape, why there's quite a lot of angular rocks, like that one there. And the reason for that is they are freshly added to the river. They've just fallen into the river because of this frost shattering and root wedging that's occurring on the river cliff. And because they're freshly having fallen off the cliff, they've not been in the river very long, and therefore attrition. So we have 3 characteristics and reasons for why, in the case of rock size and rock shape, why they may not be doing what we expect according to Bradshaw's model. Let's think about the efficiency of the channel. Well, the efficiency of the channel is obviously going to be affected by these large boulders. So we might think that actually our river is becoming less efficient. But what we can see at this particular location is that the river is much wider. It is slightly deeper now. We can see if we're getting close that the water has, 4 or 5 centimeters of depth now. And therefore there's significantly more water not in contact with either the bottom or the sides, and therefore more water is flowing freely, like we can see in the middle of the channel there, and isn't being interrupted by rocks or contact with the banks and beds. And as a consequence, at this particular location, it's probably going to be slightly more efficient. Our hydraulic radius will have grown, which explains that particular result, because our river now has more water and is flowing freer than it was before. So what I've just done is gone through the 4 key characteristics for site 2, thinking about why they are changing, why they're either increasing or decreasing, compared that to what Bradshaw thought, and giving you some analysis for why the data is showing you what it is showing you.